Welcome everyone. This is the third talk of this third season of Lightning Talks. And today we have a very interesting talk by Marcelo, which is going to be about writing static code analysis. And before we start the talk, I want to remind you that we're still looking for people who want to prepare more talks. We're looking for presenters. So if you do have an idea, please just sign yourself up or drop us a message. We're super happy to help you find topics or even refine the topics that you have in mind. We like this means of sharing knowledge, so please do sign up and we will be more than happy to have you presenting. So with that said, Marcelo, all yours. You got the stage.
Thank you. Hello, everyone. Thank you all for the opportunity. So I'm gonna present about writing static code analysis. Just let me see if, okay. I'm Marcelo from routing and logistics. And the main motivation is we already use static analysis at Glovo. And I see that you have like a potential to go one step further and start using more and customizing that for our needs. So the context that we have is we're building a world-class engineering team. We are decomposing the monolith in microservices. We are onboarding new people, and some of them, I put some of them as green in the sense that independent of the level that you come, you still have to learn about the team customs, the team good practice, and other things. Security concerns, as the company grows, the security concerns increase. We had a recent interesting Glovo engineering post about the Swift team linting formatting that they use. And also past presentations seems to show they're understanding a bit more of the compilation process might help us. Some of them, like past presentation, we had Andre talking about micro benchmarking, and then we saw at some point that we started to hit the GIT compiler because it started interfering with the profiler. So, and also we have a presentation from Andre in the GIT compiler. And for those, we aim to solve misconceptions about programming language, going one step further on this static analysis, understand the compilation process. We can customize for our needs the format and code standards. We can automate reviews and enforce project architectures. We can fix bugs across projects and reduce technical debt. And we can give high quality security advice. Given that, for one of the points, solving misconceptions about programming language, I put some of them here. So someone might say like that you avoid overloading this method in Java because I add an overhead to the runtime, but that's done statically. I will not use inheritance in Java because it can make my method calls more expensive as I have to find them in the class hierarchy. There is a compile optimization at the static level. That's called the virtualization. They help on that. You still have other reasons to might not use inheritance because of coupling, but like that's not the reason. Might not be the reason. Java optimizations on happen GIT compiler. So here you see like there is a function that has a bytecode generated, but then once I add the final to the variable, the compiler now knows that it cannot be changed. So this part of the expression in the condition will always be false, and it eliminates the code. So that's also a misconception there. And given that, we're getting into the fundamentals of static analysis. So our code passes through intermediary representations up until going to the object code. So it goes through abstract syntax tree as a result of the syntactic analysis of the syntactic parsing. And then the compiler eventually converts to a control flow graph, applies more static analysis and code optimizations until converting to the object code. The control flow graph is a a simple representation I just mentioned as part of the process. You have some basic blocks in their sequential part of code, and they relate to themselves as the flow goes. But the focus of this presentation will be the abstract syntax trees. You can see an example here and how they're constructed. The main points are it's abstract, so there's not all the information like punctuation, comment, spacing. Ambiguity is resolved. That's important because then there's a representation we can rely on and has benefits over other intermediary representations for errors and message. The granularity is higher, as you can see, for example, for the control flow graphs. And another piece important to start doing that is the visitor pattern, because that's how the Java API that those tools provide us. And the visitor pattern is a behavior design pattern. It means that it concerns the communication. It's a pattern concerned about the communication between objects, and it's important because it's an important pattern that aims to decouple the data structure from the algorithm, from the operations that we want to perform on this tree, our abstract syntax tree. There are three main components: the client, the element, and the visitor. The client is like, for example, our ST. The element, it has a method called accept in the interface that the derived classes, they implement that by calling the visitor method visit and passing themselves. And yes, so that's what done here. So the client, you can think as a subscription. So they subscribe element A, element B for this visitor. So we already know that the implementation will be calling the visitor method passing themselves. So that's what they do. So that's how the operation happens. So for our side, we'll be implementing this visit, the visitor. So on the node. So the good news is that's also like the worst case scenario. Sometimes like you don't even need to work at the ST and visitor patterns, because those tools provide high level support, abstractions to work with that. So for example, PMG provides XPath. Others provide simple programming APIs that you see. But it's still important because if you want to do something more complex, you might have to do on the ST. So let's go quickly to an example. Let's do TDD first. So we don't wanna have these Glovo non-recommended annotation. So that's what we want to avoid. And then you have one that is not valid, not compliant to the rule that you create. This is valid because it can be in the middle of some name that you still wanted that. Another notation is fine. Then I have some, then as we saw, we extend the visitor and we implement the visit method. Then now it's not created. And we have a test just linking this piece, saying, okay, I wanna derule the annotation that I have is this one that I wanna avoid, and I will apply to this file. And yes, if we run, then it should fail. But then to speed up, I just get the. So here's the implementation that we can swap now. And then that's basically like getting the annotations, if it's looking for the identifier and see if the identifier is equal to the name of the annotation we want to avoid. And then if we rerun the class, the test, now they pass. But we're gonna just a simple example of things we can do, but it's not limited. Yes, we can do like make sure, I don't know, our variables are final in the test folder when you're creating tests, and like we can have like Spring specific things we can customize even more. But so for Sonar Cube, that's the one I was using. After you create those files, if you have to add metadata, that's an example here, where you add if it's a code smell and severity. You activate the rule. You have to check if you're using the parent plugin. You have to make sure, just check it. They have like a check for the number of rules that you have. It seems to be hard coded, so you have to adjust that. And once you build your new plugin with your custom rules, you have to send to the extensions plugins folder if you have that downloaded in the platform. And now we're gonna go over more use case. So yeah, so for Sonar Cube, thanks to the infra team, you have that in the Glovo. That's all the rules. So most of the time, you don't even have to write the rules. Like for Java, you have 621 rules, and it supports many other languages. Some teams already have, in some repositories, have different profiles with different metrics, thresholds. And the Swift team, for example, has a profile with the rules. And this is integrated to other tools thanks to the infra also. Like for source graph, for example, we can see once we click, it goes to the Sonar Cube. For PMD, for those using like the sample service, it's if you created your microservices based on the samples, then you see there is a Glovo custom rule set that you also can edit. It also supports Java, PLSQL, JavaScript, and those are the metrics. And there are other services using check style for code standard and validation also. But once you go to the implementation, you can see the same thing on the fundamentals. And for PMD, that's also as you're creating microservices and importing those files, you could write like custom rule with XPath, that the high level abstraction that they give. But in case it starts to depend on what you want to do. It's not supported in XPath. Then you have to go to the Java API and do the thing we're talking about, like extending visitor and then implementing the visit method. But there are other things that we can do this step further. We could like create do static analysis to make sure that we keep our architecture. So for example, if we're implementing a new architecture, you could create a class, you could create a task for that. Also for data access object rules, for the layered architecture, you can enforce that. For as we're going to the also like MLOps and Kubernetes. So for the Docker files, we also have these configs image that can be static analyzed. And for Terraform, you have on Sonar, but also there are tools just specific for Terraform with more rules. So the summary is that there is no additional cost, tools cost. It's easy to use, most of them. Many of them are open source, and you just have to check the license before contributing or using, and customize only when necessary because there are so many rules already. So, and I do believe we can take even more advantage of that and customize and enforce our team's specific reviews and automate things. So with that, yeah, that's more resource. If you need, feel free to contact me. That's an area I like it. In back to school time, sometimes I spend time with it. So thank you very much for the opportunity.
Awesome, Marcelo. Thank you very much for your presentation. And so now we have 5 minutes for questions. So remember that you can write your questions in the Q&A section below. And then while we wait for the people to come up with questions if they do have them, I wanted to ask you one question, whether you have ever written one of these custom rules, and what was the most complex one that you have written? Because I guess you need to do this abstract syntax tree parsing with the visitor, which is kind of hard, right?
Yeah, to be sincere, like I didn't deploy it in custom rule for our team. What we mostly did was like, let's see what the available rules that we have and make sure we understand that they're not false positives, because what you can have, like depending on writing your rule, you can have many false positives, and then that's usually like you would just disable the rule because it's not being useful. But I think like one of them I think can be tricky. Trying to write was the spring ones, just because once you start to you can have corner case, and then you have to start to think a bit more on how the environment they're working on.
Okay, let's see. Wait 1 minute, see if people have something to ask. Otherwise, also remember that you have the Slack channel where if you come up with questions, doubts, or you want to know more about this topic, you can drop a message there. And I'm pretty sure Marcelo will be more than happy to answer.
Yeah, I think like also the motivation is, I don't know, like with those work groups, if someone we wanted to push more forward to this area or try to improve something, it's more like automate reviews. We see many I don't know, I have seen things like, okay, this variable could be final, this variable could be final, like these are paths that they have there, or the async annotation. If you don't enable async, that's something we can automate that, and try to make sure this. Of course, like you have to think about the corner case, implicit things and configure variables, but you can avoid errors.
How much effort does it require to write one of those rules? So if we wanted to, for instance, take the final one and say in the code reviews, automate this part.
No, I mean, like for just enable, that's very simple, because you just have to go to your config file. For example, for PMD, you have the config file in the microservices, and you just you basically, you can exclude some of them or add some of them. If you want to add a custom rule, like if your team needs a custom rule, then I think you have to reach to the platform team, because eventually you have to load these new rules to, for example, in Sonar Cube, to the extension plugin and make them available. But I would say like the main gain could be in seeing from the reviews that you have or things you want to enforce, see if there are available rules already, because you have like 600